Hello, I'm Harry Glorikian, and this is The Harry Glorikian Show, where we explore how technology is changing everything we know about healthcare. If you're a dog owner, you know how much joy dogs can bring into our lives. But there's a sad downside to being a pet parent, which is that dogs have a shockingly high incidence of cancer compared to humans. 6 million dogs are diagnosed with cancer every year in the US, compared to just 2 million people or even less. And that's in a country where there are a lot fewer dogs than people, 90 million dogs compared to 330 million people. The basic reason for the difference in cancer rates is that dogs are far more limited in their genetic diversity than humans. And there's not much we can do about that. But we can work harder to make sure that dogs benefit from some of the last 2 decades of advances in human cancer research. If your dog gets a cancer diagnosis, it shouldn't have to be an automatic death sentence. At least that's the argument coming out of a startup called One Health Company, which offers a cancer care service for dogs called Fidocure. My guest this week is the company's co-founder and CEO, Christina Lopes. And she says it's becoming possible to deliver precision cancer treatment to dogs by taking what we've learned about genomic testing of tumors in humans and using it in a veterinary clinic. In a paper published this January in the Nature journal NPJ Precision Oncology, Lopes and a team of researchers sifted through veterinary records and DNA sequences from more than 2,000 dogs. They showed that they could predict cancer survival rates in dogs by looking at whether the dogs carried key oncogenes like TP53 that are known to be associated with worse cancer outcomes in humans. They also found that when dogs were given small molecule drugs designed for humans carrying these same oncogenes, they had a better prognosis. None of this is at all surprising, since, in a lot of ways, dogs are better model organisms for humans than mice or other mammals. But what is a surprise, and what Lopes and her company are trying to change, is that it's taken so long for the notion of precision cancer care to make its way from human medicine back to veterinary medicine. With Fidocure, a vet can now submit a dog's tissue sample for DNA sequencing. The company then supplies a personalized report showing whether the animal has specific mutations that could help determine which cancer drug will be most effective. In our interview, we talked in more detail about how that process works and where Lopes got the idea for the company from. So let's listen now. Christina, welcome to the show.
Thanks, Harry. It's a pleasure and an honor to be here with you.
Yeah, I'm so glad we ran into each other and started talking and me learning about the company. I think what you're doing is just knowing enough about, the whole oncology genomic space and then how you're applying it, which we're going to get into here in a second. But it's truly it's one of those things where you're like, duh, why didn't we think of that before, right? Sort of thing. So I'm glad you're here, and I'm glad we're talking. But let me step back here. I want to just sort of set the stage, right? You and your partner Ben are co-authors on a recent precision oncology paper that says 1 in 3 dogs will develop cancer in their lifetime. That sounds a little higher than the cancer rate in humans. So let's start off with are dogs more cancer prone than humans? Are there lots of other common causes of deaths for humans, so cancer doesn't rank as high? I mean, how do we think about that?
Yeah, no, thank you. That's a fabulous question, because I think we all hear about the vast unmet need, right, of cancer in humans. And folks anecdotally learn about it. You might have had a neighbor, personally, maybe a dog died of cancer, but no one is aggregating and putting this as almost an asset class, a narrative. category creation. And we are really the protagonists in that. And let me say why. So dogs, so there's about 90 million dogs in the United States right now. And last year, 6 million were diagnosed with cancer. So you can see the incidence, the prevalence very high, because there's over 300 million people and 1.8 max, maybe 2 million cancer diagnoses in humans. So right there, you can already, see there's a big, and this is, and you can imagine the cost also to diagnose a dog with cancer. So there's probably likely an underrepresentation. Why? Why is this happening? So number one cause is really from the genetics, I think the breeding. So dogs are 10,000 times more homogeneous than we are. And for example, a breed like Golden Retriever, there's some whole litters will have, 1 in 3, 2, like very high lymphoma. Right now, the number one is angiosarcoma for Golden Retrievers. So it's really from the genetic landscape. There's a clustering, and that's a key driver. Relatedly and importantly, I work in the cross-species world, right? So I'm looking at comparing species. That's the name. One Health is actually a movement looking at what can we learn across species about health and disease. We look at cancer. We look at from the genomics, precision oncology, and AI angle. But there are folks, for example, that study the elephant, just to give you another range. Large animal under the sun, lives a long life, and actually doesn't spontaneously really develop as much cancer as you'd expect. Right. Why? They have more protective copies of TP53. So they have more than humans, humans have more than dogs. So that's kind of the let's say the foundational basis. Then we have a paper actually coming out with the Broad and UG Cancer Center, where we're really looking at the mutational, basically the oncogenes that are driving the cancer in dogs, and comparing that to the human at the tumor level. And the overlap is significant, more than we thought, in genes of interest. So lots of, RAS family, BRCA, it could be that there's a lot of, cancer driver mutations, but they're not as actionable or not as from a relevancy of cross-species interrogation. So I went a few places here. Tell me if this makes sense.
No. I was going to ask you, because one of my questions was in what way is cancer in dogs similar to cancer in humans? Why, and then, how is it that humans and canine biology are so similar, right? Because, I know where you're going with the company, but I just want to sort of get everybody else
the foundational,
at the same place.
Yes. So dogs co-evolved with humans, right? So that's a big part. And to touch on beyond the evolutionary, the coevolution and the genetic landscape is also the other part of the story, which is dogs share the environment with humans, right? Secondhand smoke. They sleep in the bed. They might eat all the scraps. You see what I mean? So there's a lot. They're lower to the ground. So there are actual breeds that have been found to have a higher propensity to bladder cancer, who live close to golf courses. There's a whole other study about dogs near oil wells and certain disease progressions that are observed that might be even like a proxy to what happens in humans, but you can see it in a tighter time frame. So there's so much to do. Let me stop there and make sure that we're setting the foundation.
No, I mean, we're gonna go through lots of stuff, but I'm trying to understand sort of cancer care in dogs, right? Because I will admit I've not spent my time trying to. I've spent enough time trying to understand cancer care in humans, and I'm still a little befuddled by that every once in a while. But is it correct to assume that cancer care in dogs is got to be behind cancer care in humans? I mean, it can't be the same. So I would guess, 20 years behind.
Maybe more.
So how does that translate into care? I mean, what is the standard of care for canine cancer right now before genetic testing and before taking precision medicine into account? I mean, in other words, if canine cancer care of 2023 looks like human cancer care of, say, 2003, can you tell us what it's like, what sort of cancer treatments could do, and where is it right now?
So no, that's a fantastic question. I would say it's probably closer to the 90s from the human equivalent. Yeah, no, really. Very stigmatized. So think, even departing from cancer, like a world 40 years ago of organ transplants, or or HIV/AIDS, right? Before, right? Certain innovation, really stigmatized, very few tools to even interrogate and understand the disease or even classify in an interesting way, right? Such that we can then guide therapy. Predominantly, if someone can even access care, and the pet parents really want the care, that's a very, very big shift culturally, where the humanization of pets, consumerization of pets is not just for Halloween costumes, it's actually for care at that most vulnerable portion of, perhaps, right, the four-legged family member's life. So the current care would be very few options of chemo, some chemo agents that are not even used anymore in humans, very few options, even for few options of radiation, as you can imagine, right? How many would even invest in a machine? So, and then if you even are aware of the world of clinical trials, very few, and the ones that folks can access might be in a university in Minnesota, like upstate New York, so I think Cornell, right? So not everybody can go there. So it ends up being who might even have a private plane, so it's really an access issue in a pretty wild way. And we're here to change that.
So, well, that sort of like brings me to the question of, so what have we learned about canine cancer in, say, recent years that make a service like yours feasible and beneficial? And maybe this is just a good time to talk a little bit about your precision oncology article. I don't know, maybe you can describe the findings in that paper. I mean, I think a short description would be that you took the same kinds of machine learning that's been applied to clinical and genomic data in human patients and applied it to dogs. But I guess you should tell us, like, what did you learn in a nutshell? Were there any big surprises? That sort of thing.
Absolutely. So we thought, given the very high unmet need of canine cancer, the desire to take care of our, family members, dogs that give us so much love, combined with some of these really interesting aspects of, the genomic overlap, right, from the cancer lens, really made it very interesting to, hey, could we actually help deliver precision medicine to dogs today, translate back what was built for humans? And I say back because we also enable, through a pharmacy partner, therapies, targeted therapies that were all tested on beagles. So we're arriving at the scene with lots of data from the safety, right? So the beagles in preclinical studies don't have tumors, spontaneous tumors, right? So here we're talking, how can we imagine what already exists out there, that there's even evidence in, at least from the safety tox angle. But now the novelty is bringing it to tumor-bearing dogs, right? That might just benefit even more from the precision medicine toolbox if we get it right, more than humans. Why? Because the genomic landscape clusters.
Right.
So the actionability, there are certain tumor types that 80% of a tumor will have BRAF mutation. 80%. I mean, there's nothing, it's really hard, right? So that breeding, you can really start getting a certain, just basically from a population point of view, right, you can really, and think now, right, to figure out clinical trials and evidence on the other side of the leash. But back to the dogs. So the idea is this whole toolbox has been developed, right, this century for humans. It's quite de-risked. Why can't we bring this to dogs? What do we have to do? So we basically have a genomic test. We researched everything under the sun, Foundation Medicine. We spoke to the leadership at Memorial Sloan Kettering. I mean, you know, we went all over to find how can we build the best test,
right,
at the, you know, more accessible cost. So we've done that for the tumor, and we're building from the liquid biopsy right now. So in case that's step one. However, that's not sufficient, because if you don't have the therapies, what is the point of information if it's not actionable? So we come very much from that lens of, we want to intervene. We want to intervene at the right time, the right place, and build that machine. So then we help enable about 12 small molecule targeted therapies that, you know, the original molecule has been FDA approved for humans. So again, very well understood. And in this, we are figuring out the dose, the regimen, all sorts of things. And there's some very interesting aspects in this, which is, one, there's no standard of care for dogs with cancer, because standard of care has an implication, an ethical implication of you almost, you know, you're not practicing good medicine if you're not doing that standard.
Right.
And hey, who can go, right, for a course of 7 weeks of chemo and take all that time off, right, and drive potentially very far and pay out of, so there's a whole paradigm that just from the human does not work in the, right. So that's one. Two, what's also interesting is that there's just this vast opportunity to bring in. Small molecules are, for us, particularly interesting because you don't have to do the species shift, where in larger molecules you do have to caninize, and that does not mean a religious connotation, that means a species. So it's not impossible. We have folks in our SAB working on that, even as far as CAR T, but the lowest hanging fruit is the small molecule world. So we basically have figured out a lot around dose, regimen, a whole world, and help deliver this Fidocure is the name, toolbox at the point of care. So we're in over 900 veterinary clinics. So think of turning the veterinary clinic into, right, like almost leapfrogging. And it gives you that idea that, wow, if we can leapfrog so quickly for the veterinary space, we may, depending on how we figure things out, be able to even leapfrog the human. Right now, we're taking what's from the human side, right, to the dog, but you see the opportunity. Yes. Another really important point. So as we're delivering care, we're learning what works. We track the data. So we're at heart we're a data company at heart from day one. This was not something we then built a data set and now it's messy and we mine it. No. From day one, we had the luck to meet Amy Abernathy at Flatiron very early on. She was fascinated by how there's no HIPAA in dogs. So if you think about it, if the dog, if there's concordance of the genomic landscape, if the cancer journey recapitulates, and that's part, and I'm getting to the Nature Precision Oncology paper, where this is what we set out, our hypotheses, and this is what the paper, peer-reviewed, we did the paper with Stanford AI Health faculty leadership, James Zhu, who has been deep in bringing AI to the Flatiron data set. So you see how it all comes together at some point, right? So if Amy brought the concept of real world evidence, we in clinical genomic data sets, we essentially recreated that, and we had to actually go from zero to build it, put it together, the clinical and the genomic and the longitudinal data set. Because of all these folks who had already done it in the human side, we already knew some of the pitfalls to keep the integrity of the data from day one, what we needed to capture. So let me stop there and just make sure, and then I'm going to get into the paper results. That's like setting the stage, because the essence of the paper is the data set and the
which is of course
points.
My favorite part. I mean, where can we I'm always looking at companies and people in the space where there's some canonical data that you can see how you're going to take it forward from where you are, right? Where it's not just going to sit there and
Yes.
not grow and not be reusable in a sense, right? But let's step back for a minute. I'm sure that there are dog owners that are listening and dog lovers that are listening. What's the actual, say, Fidocure process? I mean, maybe you can just walk us through it step by step. I mean, when does it come into play? What kind of cases warrant, DNA sequencing? How does the tissue sample get submitted? What kind of sequencings, do you do? Is there a panel that you guys are looking at from a mutation perspective? What does a report look like? And then at some point, do you guys actually help the veterinarian or the dog owner get the drugs that they actually need, right? So what does that circle of life look like for this process?
Yeah, no, that's we thought a lot about this, and actually the tools we chose from, say, oncology toolbox we were very mindful for the setting of the veterinarian, number one, and pet parent, right? Obviously the patient really at heart, but those who love them and care for them. And how could we make it easy? So that's part of being a bit in Silicon Valley. Our early head of product was from ideal, like human-centered design, and really thinking how to make this very, very, how could we bring almost a distributed trial? How could we bring this toolbox to where it's needed? So for this reason, so we come in as of right now, once there is a cancer diagnosis, okay? So that's, we're working on things ahead of that, but right now it's, sadly, bad news. Fido Fluffy has cancer. Good news is that potentially, right, we can sequence the tumor and find out, given the genomic landscape, the phenotypical information, our population health data, the Fidocure data set, what might be a really promising path from the precision medicine angle. So the how, we work with the clinician. So the veterinarian is the clinician for us at the point of care. And we essentially, whether the pet parent comes in asking the clinician, or the clinician learned about us at a conference, read the Nature Precision Oncology paper, however they hear about us. And it's been remarkable because with very little really effort on the commercial side, we've, close to 1,000 clinics. It's the need is very there, is what I would say.
Right.
So however, we come to play, the clinician can set up a time with us, and we essentially do a very white glove. Most would see ourselves as Sherpas in the cancer journey. So we're there to help the clinician who might have not had even genomics training. Even the veterinary oncologist, the most high trained folks, you'd be surprised, right? Again, that gap. And so we bring all of that to them and make it as easy as possible. So I don't need a rebiopsy. We use what was already submitted to get the histopathology report, the cancer diagnosis.
Right.
So that's, we're trying to be as less in no repoking the dog as much as possible. And so all the clinician, if that parent and clinician decide, it's a 5-minute Fidocure.com sign up. That's it. And we have a whole team, Harry, that works with all the pathology labs, not mostly in the United States, but even internationally, believe it or not. And we just handle it all. Like we figure out, and we've created partnerships, obviously, to make it easy. So behind the scenes, we pull the tissue. And with some labs, we do it super fast because we're already very integrated. If it's an academic lab, it might take longer, but we know there's a cost of waiting with cancer. So we go as quickly as we can. Tissue is just, paraffin embedded, just the really basic, arrives at lab. lab is a CLIA certified lab. So it's the same lab that would be running human, really sophisticated. So that same quality. However, we use next-gen sequencing, a panel, right, to keep it focused. We've done whole genome, we've done everything under the sun, but we've nailed, and we keep evolving as we learn, right? Because remember, there's not been as much of the research dollars into the canine genome as there have been for humans. So that's why, Harry, without having then the drugs and the outcomes data, you see how that informs what gene, you see what I mean? It's the learning. Yes. It's exactly what you were hitting. It's that learning database that really is the key. So we keep evolving the panel and adding what we learn as also the science evolves. We partner with a lot of academics. So as the science, basically, we understand more about canine cancer, we also add the genes. So we keep that moving. Obviously, we infer a lot from the human side because we have to start somewhere. Right. And so that's, the tissue, then the report is very modeled very after. So say, a couple of weeks pass, we're pretty fast because, again, the cost of waiting. We send the report to the clinician. We give a consult to the clinician to help guide, right? So sorry, Fluffy has cancer, but good news, there's some actionable genes we found, and here's what that means, right? There's some targeted therapies or some prognostic information in this report that really matters to the treatment. Right. And we guide on a really high touch individual basis at the clinician level. So that's our interface. And essentially prep the clinicians so they can deliver that information. And then on our own, in our own platform, they can order the targeted therapies. So we make it really, and we help in side effect management. Like we're there every step of the way. So let me stop there and make sure that answered your.
No, that's great. I mean, I want people to understand what we're talking about when we're, because they're listening to this or when they're watching it on YouTube, but they can sort of, get their head around this process. But, I don't know the answer. How many good targeted therapies are there for specific kinds of canine cancer? I mean, I'm assuming that you're generally using human approved therapies on dogs.
So by and large, the if you think even cancer, not cancer, anything, drugs approved are generally approved for humans, period, right? So if the tiger in the zoo has something, they're probably in the cardio, they're probably using a human drug. So that's kind of like where we're coming from. Okay. However, FDA does have a Center for Veterinary Medicine, and we feel really blessed they have put out even guidance on real world evidence. Isn't that cool? So, we can really play a strong role there because we are very much the leaders in real world evidence in veterinary medicine, starting with cancer, but, the approach can be used for other disease states. So historically, in terms of what has been actually approved, there's very few drugs that are actually approved for dogs, like really for the species. Okay, but there are a couple. Okay, but I'm talking a few. Then when you depart what is approved, it's you're really using in an extra label, off label. I forget now which one. It's very specific capacity, and there's a regulatory framework that's similar to the analogy with the tiger in the zoo. If the animal's life is in danger, the veterinarian, in alliance with the pet parent, can actually pull really anything that's out there.
Right. Okay.
The issue then becomes dosing, excipients that are mixed in that the dog might not really, react well to. You can't just go to CVS, take ibrutinib and chop it up. So there's some work that needs to be done there, and that's what we've done, and we're so proud of it, because it's really opening up a whole access. And imagine a world where, and we're doing this, we've deployed over 13,000 targeted therapy orders, partnering with a pharmacy. So imagine these are going to the home, right? I'm a dog lover, obviously. And so even taking my dog for wellness check is such, like, they don't want to go to the vet, right? It's like a big ordeal. It's a family affair. So we're just making it much more really, basically for our times, right? So there's not this, cancer, that stigma, dog cancer, almost think, right? Like 1990s, maybe earlier, almost a death sentence. No, not a death sentence. Absolutely not. We're demonstrating that. And I know we want to get to the paper results. So we're setting the stage.
Yeah. So, but now's I think a good time, because you said I'm a dog owner, is like taking a step back of the origin story of the company. What happened? What interest, what event, what something happened that put you on this path to say, I'm going to start a life sciences company, and it's going to be in canine health, and like this is going to be what I'm going to do next?
I know it sounds wild, right? So from a kind of like real impetus, I actually took care of my dad with lung cancer, end of life, the whole journey. So, you just start getting in, learning, why can't I access this drug? What happens here? Like you're just in it. And we've had family dogs that had cancer, and you start to think, wow, there's metastases, there's similarities, and similar, there's some of the drugs, chemo, or at least the category. And it's like, wow, okay, that's interesting. But in learning about basically how, R&D, right? And there's a lot that, let's say, is broken, or why drug prices for oncology drugs are high. But one of the issues, and that I started to learn by being very close to the veterinary community. My husband is a veterinarian, and we would chat and say, hey, at vet school, we work half of the day or part of the day in lab animal science, right? So working in R&D setting, and the other half you're at the clinic of the school, the hospital, and you have dogs coming in almost with the same disease you're inducing, so is there a way to leverage spontaneous disease, naturally occurring disease, in a way that actually helps the animals? That's number one. And that's the beauty of our almost circular economy, very impact side of the company, which is we're looking in a very progressive way of how can we help on one side of the leash, the dogs, and then generate data to help the other side of the leash. So it's not the either or. So I'm very fascinated personally as a mission. I'm a bit mission person myself. Coming from Brazil, I've worked really in getting the resources, capital, people, technology to what I felt were very big unmet needs. So all my career for the last 20 years, I've been for sure doing that, whether it was infrastructure, water, and you end up going to healthcare. So I've worked in emerging markets, so Brazil, Turkey, Vietnam, all sorts of countries, and trying to bridge what is the highest need, and then figuring out how to capitalize it, how to bring the decision makers, government, financiers, the whole architecture. So I've been very much in that mission. You start getting into health, right? You just start working, and I started to get involved in global health. So that's my other, from a professional lens, this is how it kind of came together for me, which is I joined the advisory board of Planned Parenthood for the whole Western Hemisphere, okay? With Margaret Sanger's grandson, imagine. And 30 million health services delivered a year. And the entire mindset is how can we deliver that last mile of care with almost things that already exist and do it economically. So an example, right? Bolivia has one of the highest cervical cancer rates in the world. Cervical cancer is preventable. You know that.
Right.
So guess what? That hustle of, how can we negotiate vaccines and then, right, to get HPV vaccines, to get to that delivery of care. So that actually inspired me to have that mindset of how can we use what's already been built in a totally novel way. I would think a lot about this. I would talk a lot about serving those that are voiceless and marginalized. I didn't mean dogs in the moment. So watch what you say. So I said voiceless. And so dogs are, so I just didn't think the species that came as a surprise in a sense to my own self. But I've always liked wedges. I've always liked not obvious asset classes, from a more finance point of view. I've always liked creating, so I worked on helping develop the Brazilian protein sector as an asset class, IPO, the whole thing. I was a managing director at Cerberus Capital's, one of the largest PE firms in the world. So I saw a lot of how capital, how people, how power moves.
Right.
And coming from a mission point of view, what are really underserved, but high potential, right? So that's you can see how that then leads me to, wow, this is a unmet need for dogs, unmet need for humans. There's evidence we can generate. So that for me is like the dream.
Yeah. So I mean, let's go there now. So okay, you're doing the work on the dog. I mean, I'm not sure that people totally appreciate the HIPAA advantage, I'll call it, right? The other fact that you're centralizing all this data, and we all know that centralized data seems to give you nuggets or insights that, when everything is scattered all over the place, it's a little harder to get to those same insights. But you actually want to take, and I think your term is both sides of the leash. You want to take what you're learning with the dogs and the therapies you're using and translate that into what might be used in humans. Now, I'm going to assume is it a lot of the same therapies, but just understanding how to use them better? Or is it also working with pharmaceutical companies on the development of new therapies because of the data that you have?
Yeah, absolutely. So just to backtrack, what the Nature Precision Oncology paper, peer reviews and validates is one that this whole, this initial set of targeted therapies designed for humans is working in dogs. So we're showing in some contexts like 3x the control improvement, right? We have another paper coming in the canine equivalent of hemangiosarcoma. And it's astounding what we're doing, really, if I may say. So really turning and not adding a month, no, adding like, a year, which in the dog world is a big deal. So the paper demonstrates that. The paper demonstrates that not just, we have this other work I mentioned before about the genomic landscape of the tumors being very, right, there's high concordance. The paper takes it one next level, which shows the journey. So what a biomarker, the predictive aspect of, and that's where the AI, the tools really mine the data of when we see a certain mutation, does it mean good news, bad news for canine cancer? And is that recapitulated in the human world? So when you see that mutation in the human world, does that have a similar prognostic, right? Like predictive power. So we're very much, that's what the paper really shows. And the answer is yes, we're seeing, right, concordance on the journey. We're seeing the drugs applied to one species to the other works. And so what that helps us really solidify is not only precision medicine as a toolbox is really beneficial for dogs, and that's amazing, but also the learnings now, this opens up the door really wide for us to think about this as a very, very large in vivo, almost AI data set, okay? So how do we work with that specifically? So we do partner with biopharma. We actually have a lot more inbound from the animal health, which is very exciting because I think we're part of actually getting them excited about, hey, we can do this. And can do it in a right accessible way, meaning evolve the toolbox for dogs. But from the human side, we already have a proof point. So we partnered with ASI, and that's public. We presented some of the results at AACR and the American Association of Cancer Research. And we interrogated a drug. In this case, it was a drug that had already been FDA approved for one tumor type, breast cancer. And they were looking to interrogate in a sarcoma that we see often in dogs. So we generated the data. It helped ASI make the decision to go to the clinic. The drug is at the clinic, Mass General, and a few other trial sites. And what we saw in the dog, this is really important, was predictive of what they're seeing in the human clinic. It also helped generate evidence in that setting where the traditional preclinical models, and I mean that really clearly, right? Like models, right. They weren't convincing enough or sufficient enough quality-wise for a company to make the decision to go to the clinic, because you and I know, right? Going to the clinic is like, just recruiting patients right there is super hard, right? So we're part of that engine. We're so proud to already be playing part in that one. So you can imagine now we are partnering with other biopharmas. And I really love one of your podcasts, Harry, about the in silico world, right? And drug discovery, because think about this world where you have now an engine of discovery, right? An industrial type, not that artisanal, right? Shot in the dark, one target, one drug, take 10 years, oops, it didn't work. You now have this potential world of molecules coming through, right? And how are you going to figure out from that in silico, in vitro, maybe traditional animal model world to the clinic? How?
But it's interesting, right? Because I don't think most people understand or realize that the dog model is actually a better model, right? Because like if I had a nickel for every mouse that we've cured, I mean, we've cured cancer in mice. I mean, let's face it. We have
Alzheimer's, you name it. Yeah.
We've done everything. That mouse, that should be a superhuman, ever-living mouse, right? For
they
everything
should be
that
pets
we've done.
now.
I mean, you know, if I could get rich off of every mouse that someone has come, and we fixed this problem, right? But translating from a mouse to a human is not, you know, it just doesn't happen. And the second thing is we genetically manipulate that mouse to do what we want it to do, right? So what you guys are looking at in dogs, that dog spontaneously, right? Or maybe I should say naturally, because of its genetic predisposition.
It's spontaneous
develops
or natural
that cancer.
Disease. Yeah.
Right? It's a more real world process, as well as the biology, and you're going to have to correct me because again, I'm not the canine expert, is more analogous to human than the mouse would be.
Oh, yes, absolutely. And actually, we talk about that in the Nature Precision Oncology paper. And because of the coevolution, right, and all of those aspects, the shared environment, right? And, you know, really importantly, this idea that, yeah, so basically like all of the aspects we've been talking about really put the dog in a really prime location. And the interesting thing is, as we see signals, right, of what works in the dog, fantastic, we're going to help accelerate to human, but we can also then, hey, let's bring this to the dog market, right? So right. That's interesting. And one other example, just for you to know, so we're really making this category, like creating this category, right, in the world. Ibrutinib, for example, Imbruvica, which is a like cancer drug, I think now owned by Janssen. It was a very big deal. It was one of the first, right? It was sold, I think, 20 billion, 40 billion. It was gigantic when there was a transaction. But what you may not know is that that drug really came to market because of pet dogs. They did not see a signal in the traditional preclinical models. And someone had the idea, hey, don't dogs get lymphoma? And they went to a vet school and they recruited and they saw a signal. It wasn't even exactly, but it was from no signal to signal, right? And so, and in cancer world, that's a big deal. And that then led to the so that's, that was an important, and there's been a few other other drugs, and often the biopharmas don't talk about it very much, but
Right.
It's been used more than you imagine. And because I'm quite close to all the, especially at the research side on academics, I really know. So there, it's used more. What we're doing though is doing it at scale, right? Because when you also do these kind of clinical trials, if the school is very far, right, you're going to have the same recruitment, the same issues you have, maybe not the same, but with the human setting. I mean, and this is where Flatiron, right? Like we're very inspired by how can we learn and take real world evidence at the point of care, at the everyday clinic, and understand more, and then we take it to the next level to bring the actual intervention to that clinic. But so let me stop there and make sure we're tracking.
No, yeah, I mean, I just wanted people to sort of understand that in their mind, right? Because they don't necessarily, most people don't follow all the pieces of the puzzle that we're always dealing with in drug development, right? And again, like, nobody ever calls me with dog results, right? Everybody always calls me with their mice results that, they got from Charles River. And Charles River makes a business out of genetically manipulating that mouse to give you that expression that you're looking for, right? So it works, we use it, but it is unnatural if you think about it in how things are evolving. So I don't always expect that one result is going to translate into the other. But what's your vision for the company overall? Like, where do you see, I mean, obviously conquering the dog market would be first step, but where do you see things going as the company grows?
So yeah, thank you for asking. We've been really lucky to have fantastic capital partners. So A16Z Bio, Polaris in Boston, we did Y Combinator. That was really important for me as a first-time founder. So we feel really, we were realizing our promise of what we said we would do, which is to build this very deep and large data set that's a learning and breathing data set. The AI community is really rallying around us, and what they're so excited about, and that's in the Nature Precision Oncology paper, is that when we see a signal, right, we see it, right, like a phenotypical interrelation to, so dog, tumor, genomic, drug, that then we see an interesting result, we can then take that signal and further validate, and we can do it from a unbiased data first point of view.
Right.
So we let the AI tells us what matters. Okay. And that's magical. That's like magic in the AI world, because think about it in the human world, right? Even to build those data sets, right? Think Flatiron Foundation, Roche bot, right? Takes a lot, $1 billion, right? And then, okay, great. You have this data set. Fabulous. Let's see what signals we're seeing. You know what that means if you now want to really take it and validate a signal at the clinic. I mean, we're talking a very long time, a lot of resources. So that dynamism of a signal to then putting it back into the algos of our algos, right? We're seeing a better interrelation between this drug and this BRCA gene, like that. So it's amazing. It gives me the goose pimples. Like it's really, and the AI community is like, wow. And that's James Zhu at Stanford. He's, really rising, publishing prolifically a lot on the Flatiron data set. And so for him to see our correlate data set and be able to, to do so much, really guide, right? Like intervention, it's a really big deal. So that's generating that evidence, the AI capabilities is extremely top of my mind, extremely. Like this is it. How do we do that, right? We need footprint at the veterinary clinic. So in the beauty is that we only care about what's working, really, like meaning it has to be, we're looking for the signals of what we're seeing that's positive, impacting the pet's life. So again, that very virtuous cycle. So we keep refining things for that. And in that, then looking at the other side of the leash. So footprint for the clinic is a big deal. And then as we get more data, we're now, since we published the Nature Precision Oncology paper, we already doubled the data set. So we now have a whole other world to mine, and we're already doing it, where we can interrelate more, we can get more insight. So the data flywheel is really, it's a movement. And, you know, that is how we think of it. I would love at some point to bring in the pet parents more from a data angle. So we're very close at the Broad with Count Me In. So learning from them, how they brought the patient and the patient data, in this case is pet parent, from a data side, it's very interesting. I'm interested, and I've been learning myself, how could we, and we're partnering with some folks, how could we use histology, digital histology to interrelate and back into. So that's the world I'm into. And our pipeline right now from the biopharma side, we have, as I mentioned, the animal health side wanting to really dig in and, okay, what can we figure out? Better diagnostics, better drugs, right? And that's fabulous. That's really exciting. And then on the other side, from the human biopharma, here's what folks are interested in. They want to see a combination of their drug with another drug that's really hard to figure out in humans. They want to see just their drug in dogs. And guess what? They want to use it to help recruit humans.
Yeah.
Yeah.
I can see, yeah. I can see that.
They want to learn, as we're developing liquid biopsy and minimal residual disease tests, how could we track, right, the disease progression and intervene better and quicker, right, as cancer, right? Like, so those are all the things that I'm really interested in. And then I think later we will be getting more into the immuno-oncology world, because remember, the dog has an intact immune system.
Yes.
Has microtumor microenvironment. I mean, there's so much already happening there. It's just, again, from a feasibility and, you know, impact. We live in that quadrant, right? Like high impact, high numbers.
One step at a time, right? Being somebody who funds startups, like one step at a time. We want to make sure that we're successful in the first few things we're doing.
Exactly. And as we see signals, you know, I would love at some point, again, I'm giving you the roadmap, right? And partnering with brilliant folks like yourself and in your world of, you know, what are we seeing that's unique and novel that, you know, might be very valuable, and who knows, from both sides of the leash, right? There might be a configuration of, here's a combination of drugs that we're seeing really, or triple combination. We see that. That's interesting in this context of cancer. Does that can we do something, right, can we do that? Can we partner with someone to really bring that to market for dogs? And does it recapitulate a setting in humans that we feel strong enough that maybe we could, you know, with the right partners, like move it to the clinic and see?
Yeah, I mean, if you think about HIV, it's a combination of drugs, right? Where we're making, it's not one, right? So it's a combination of, I mean, and let's face it, biology is only going to have so many moves. So if you can actually block off a few of them, you might be able to, you know, have more of an effect. But, you know, it's funny, I almost feel like you're going to move faster in dogs than I'm seeing everybody else move in humans. And for all sorts of stupid reasons, it's not moving forward faster, but it is what it is, right? The healthcare system is a little broken.
It's very dysfunctional. So here's how I see it. Like the cover of Cell, I believe this month, right, is a lot about cancer and the heterogeneity of cancer, and it's really many diseases. And so if we can develop tools, so like, great, that's all being learned at the human level, right? And we know that so much of it is recapitulated in the dog. So we can, without investing all that, right, to get to that, we can take the same approach and learnings. And you're very right, Harry, and this is where I want to rally the animal health community, and really rally, because this is a movement to and that's where the pet parent is like a patient advocate, if you think about it that way, where we could be moving faster. We could really be optimizing, right, whether it's genomics, small molecules, combinations of drugs, methylation, all sorts of tools that we're already understanding, the lowering the prices in genomics, right? So figuring all that out, then bringing the AI tools, right? So we can really create this very intelligent system and actually leapfrog. You're right. The dog has the potential for us to do things much faster. there's, let's call it a more elegant regulatory framework compared to humans, and beautifully,
and much broader flexibility in I think that there's an open field here to sort of.
There absolutely is, and I'm also thrilled to see some very big players come in from the insurance side, pet insurance, because that's still pretty low penetration in the United States, maybe 3-5%. In England, it's like 50%. So and so, I just thought of like the dog and the queen, the past. So like actually the dog really matters. So I'm a little bit joking, but you can see the potential. And I'm excited about some big backers coming into pet insurance, because that would be one of the mechanisms to make this accessible. Being from a country like Brazil, having worked in, helping deliver care in Haiti in the middle of like a natural disaster, I'm very, very obsessed. And then obviously we all got sensitized during COVID, right? About that last mile of care and how that really closes the loop, including who pays for it, right?
Right.
So we're excited to also partner with some of these insurance companies to help them understand that, you can actually improve results. You can underwrite canine cancer. You can do it, and you can do it in a way that doesn't, break the piggy bank. And so we see ourselves in a very, the data set as the core, right? How we get the data set is we need the patients and the pet parents and the clinicians. But as we build from the thousands of dogs into the millions of dogs, there's a lot of use cases, including how to use the data to help predict for insurance, but also for predictive health. So that's kind of in a nutshell how we see it.
Well, I wish you incredible success, because I can see how the data that you're generating is going to have applicability to humans for sure. But even how some of the papers that you might write on the process may influence changes on the human side, because you can actually point to something that's working. And so, I almost want to say, like, if they got this process working in dogs, like, can we get it to work in humans, right? So it's, it would be an interesting case study to see how elegantly it might be implemented in the dog side, where we're still, stumbling in the dark on the human side, which is beyond my understanding.
Absolutely. And that's why it's imperative in our company, we really have representation of, we love clinician scientists. So I say this also as a call to action. So we have from the veterinary side, we have from the human side, and we find it very important that they're both at the table. Maybe the phase one is from the human clinician scientists that are helping to nudge the veterinary world, right? Hey, there's this has been well understood. We can go that way. We can improve, actually, because exactly the thing, precision medicine, right? Our actionability is much higher. We have a lot of flexibility, not having the guidelines. You can go, right, with the vision of insurance coming in. You can see how this is an ecosystem that's just beginning, and it's so powerful. And so, so basically we could there's an opportunity here to really redesign. And then the learnings, and that's a lot about the paper, Nature Precision Oncology we're talking about a lot here, which is, right, what we see, we can then start learning for the human side. The learnings can be applied and maybe break some of the paradigm, or can just be from, when I think of someone like, like Amy, right, Abernathy, she's preoccupied with evidence first and foremost, high quality evidence generation. So if you think about it that way, right, if we can create, right, like really bring this at a certain level, and that's going to be an exciting also chapter as we, understand more the FDA and real world evidence in the veterinary context. Like, how could we really solidify the level of evidence such that we can move the needle, again, both sides of the leash?
Now, I wish you great success. It's been
Thank
great
you,
having
Harry.
you on the show.
Oh, so much fun. We could do this another hour easily.
Excellent. All right. We'll talk soon.
Thank you.